Our next discussion will be joined by Mr. Kent Rominger from ATK. It will be sponsored by Liberty. Mr. Kent Rominger is a 5-time NASA shuttle astronaut, veteran, as well as having flown 2 as the mission commander, logging over 1,600 hours of space travel. And I'm pleased to have him join us for this great discussion on this new exciting things. So we welcome to the stage.
All right, thank you. Thank you. I really appreciate this opportunity. And I have one goal today. And my goal today is to just inform people what Liberty is, what it's all about. And I think the best way for me to do that is I've got some slides. I've got 30 minutes. And by the way, I was planning on using no more than 20 minutes for me to talk. And then what I would love is to field questions from the audience. Because inevitably, I'm not very good at picking out all the areas of interest of the folks. So I've got some slides that hopefully will help you come up with questions because I would love to address any questions. And feel free to ask any question you like. Matter of fact, a lot of times I tell folks, hey, you can't hurt my feelings. If you're thinking there, if there's a tough question, or if it appears that I said something that you just know is flat not true, call me out. Say, no, that can't be right. You said this, and that just doesn't sound right. I'd love to have that kind of discussion with you so we can further understand Liberty. So with that, I've got a video I'm going to start out with. It's just about a 60-second video to help kind of visually show us the Liberty system. And so this is kind of currently where we stand on Liberty today. And also, it's not all that far from our starting point with Liberty. It looks like we didn't get the sound. Now we've got it. All right, thanks. So that was pretty fast and furious, but what that tried to show is with Liberty, we do have hardware. And so the first stage, the 5-segment booster, has been test fired 3 times. The second stage is the core of the Ariane 5 that's flying today. Obviously, it needs some modification for us to put it on as a second stage. And then you saw the composite pressure cell on our capsule, the composite crew capsule that we're flying as our system on Liberty. And what wasn't on there was the abort system on top, MLAS. And given the time I had today, I kind of didn't put a lot on the abort system in there, but if you're curious at the end, we can go into that as well. So with Liberty, it's a complete system. And I say Liberty, the rocket's Liberty, the capsule's Liberty, the team is Liberty, but ultimately the service, the entire service is Liberty. So we control the manufacturing, the integration, all the hardware. But the reality of it is the customers. We're providing the service to the customers, and obviously NASA and Commercial Crew is one of those. But we are targeting other customers as well, from some of the countries like Brazil, Costa Rica, Australia, India, to name a few that we've been in touch with, because they do have interests in flying astronauts from their countries for their nation on a system like Liberty can provide. The team of Liberty, and real quickly you saw some of the larger suppliers show up on the list, which Astrium, to the tune of 120,000 folks, is on our team. Lockheed Martin, I like to tease them as my little subcontractor doing my spacecraft for me. But along with it, we've got Moog, Hamilton Sunstrand, Honeywell, Aerojet, L3 Communications, Who am I forgetting? And in your mind, you're probably thinking dollar bills. When we start ATK, when we start talking about companies like that, a lot of times you may be thinking, hey, this is probably going to be a very expensive service to buy or rocket to buy, and it's not. And so I'll get into that later with you all, but if I didn't, well, hopefully that planted a question that we can talk more on it. So my workforce, I would submit, is probably the most experienced. Our team on Liberty has got to be, if not one of the most experienced in the world when it comes to putting crews into space. So obviously, if there's anybody here from the Russians, they might stand up and claim otherwise. But for, I guess, commercial space is really in text how I would say that. The other one is rapid execution. I'm going to fly my first test crew in late 2015. And that's another one, too, where people will say, now come on. Your rocket's never flown. You've never integrated it. You have a capsule that is effectively new. How are you standing here today in 2012 with a straight face going to tell me that you can fly a crew in 2015? And so here's the reason. Here's how I can do it in 2015. A little bit of it is my team has past performance. And I'm sure you're immediately going, hey, wait a minute, your team. The 8 of my integration folks on Liberty came from Lockheed Martin. They came to us about 6 years ago to include the launch director that launched the first Atlas V. So these folks grew up in the integration world, in the Titan world, and then the Atlas world. And on the Atlas V, they basically were given, from the time they said go, they successfully launched that vehicle 3.5 years later. So if you look at what we're doing with Liberty, I'm about a quarter of a year more aggressive than that 3.5. But my starting point is further along. So the first stage is the CDR level. It's actually ready to fly. The second stage has been flying as a core. I've got to airlight that second stage, that Vulcan 2 motor, which interestingly enough, in technical meetings just a week before last in France, the SNECMA folks are pretty convinced the existing igniter will light it in orbit, which is kind of amazing. If you come from the world that I grew up in with NASA and the SSMEs on the space shuttle, air starting those is a major undertaking. In the case of the Vulcan 2, it's a simple gas generator design engine. Its little brother is their upper stage now that air lights successfully, it has for hundreds of times. So we are developing a little bit different igniter. It's a little bit longer, more capable. We don't think we're going to need it. What I do have to do is make sure I have that engine conditioned, that it's in the start box. And so during first stage now, for those first couple of minutes, I've got to do the same conditioning on that engine that it's provided on the ground. I just continue that during space flight. But we're well underway to that. The other thing with the second stage is on the Ariane 5 as the core, that stage is lifted. It's actually lifted into the air because it has a couple of strap-on solids on the side of it, and the thrust takeout is at the top of that stage. I guarantee you, sitting on top of my 3.6 million thrust engine, it is not being lifted. It is being shoved. It's being pushed into the air. So what that means is structure-wise, I've got to have a thicker tank structure than it is on the Ariane 5. Astrium just 3 weeks ago completed the initial testing on their structure. And the great news is their existing tooling in France will produce my tank right in line with their tanks without any major modifications. So that's all going great on the second stage. Now we get to the capsule. And so capsules, even though compared to something like the space shuttle are relatively simple, are still very complicated. And whenever you put humans on anything, they're very, very thorough. I have the luxury, along with Liberty, of first of all, thanking NASA for when commercial crew was selected and rolled out. NASA said, okay, industry, we want LEO, we want you to take over LEO. We want to depend on you to getting us to and from space station. And we don't want to be your only customers, right? We want you to have a business that will close on its own. So we will help with some funding for those that are selected. But also what we'll do is we've got 5 decades worth of experience, intellectual property that's available to you. So industry, you're welcome to come and get it. It's really the taxpayers that paid for it. So anything we have, that the taxpayers have paid for, we will make available to you. And NASA's been very good in that. As a matter of fact, I have Space Act agreements with 8 of their centers. The first stage, obviously, NASA developed that hardware that's being accessed, we're getting our hands on. The second stage, the European Space Agency developed that for their Ariane 5. We're leveraging all the investment that went into that. But kind of like the first stage, my capsule, the composite crew capsule we'll get into later. But the reality is, we industry, ATK, being one of those partners, have been working with NASA since 2007 on that composite pressure shell. And we're also leveraging a lot of the work that NASA and Lockheed are doing on Orion. My next chevron here says safest system available. This is what I'm passionate about. And one of the reasons I'm so passionate about it is I was the chief of the astronaut office when Columbia didn't return home. And it became very evident to us that, the space shuttle is phenomenal. Nothing has ever done what it has been able to do as far as taking payload to orbit and bringing payload back home and being reusable like it is. So it truly, truly is phenomenal. It also, though, when we sat down as an office and looked at and started doing the math, we realized if things didn't change significantly, we would run out of space shuttles before we wanted to. And the fact is, it just was not a safe enough vehicle for the long haul, and which made us realize we need a replacement. And by the way, we're in the 21st century. We're good enough to have a replacement that is an order of magnitude safer than what we have today. Liberty meets that. It absolutely meets that. So NASA's human rating requirements, their standards, their certification process that we have not yet seen, but I expect to see rolled out in about a month or so. With Liberty, I know no reason why I cannot meet all those stringent requirements because it was designed from inception. Every major element has been designed from inception to meet NASA's requirements. So now you may have a question, hey, but wait a minute, you have a European second stage, and you said your system was designed to meet NASA's human rating requirements. And what I will tell you is when the European Space Agency developed the Ariane 5, it was developed to lift the Hermes spaceplane. And although to the letter of the law, they did not put NASA's requirements as their requirements, they had NASA's human rating requirements and developed that system with the intent of meeting NASA's human rating requirements, or something very close thereto. Business case. This is Liberty as a commercial endeavor. And so that business case is probably the biggest bullet on there. If we don't have a system that's competitive and will keep us in business, then none of the other things matter. The fact that it could be the safest vehicle ever designed, that doesn't matter. What matters is you have to have an offer and you have to provide a service that's competitive and has a very strong business case, and Liberty does. And the fact is, when you look at the commercial crew providers out there, Liberty is one of them that now we control the entire stack. So all the hardware, the service, crew is our first launch, but we also are going after cargo and satellites. And the Liberty has a real great sweet spot for large payloads to LEO. The fact of the matter is there aren't that many large payloads that need to go to LEO, although there are some. GTO is also an area that we are looking at, and we're developing a third stage for the GEO market as well. So a few key attributes, and some of these are already keyed on, but the fact is, when it comes to human rating, I believe this is a true discriminator for Liberty, the fact that we have designed it for that. Part of what you do, if you sit down and look at it saying, how do I come up with a system that's the safest, most reliable there is? And the very first thing you do is you make it simple. You try to make it as simple as possible. And if you look at our past and where failures have happened, one of the things that drives failures in the past is if a system is kind of complicated. And you can have interactions between the systems. Challenger. Challenger is a prime example. Our solid rocket motor had a leak in one of the joints. It severed the strut on the system, and it was a very bad day. Had that happened as an inline, say that was a joint on Liberty, and by the way, that joint's been redesigned, and we've got 221 flights showing that our system joints are very robust. But had that same event happened on a system that wasn't as complicated like Liberty, chances are we would have never even known we had a problem until we recovered that first stage. It would not have resulted in a catastrophe. Same with Columbia. You know, look at Columbia and say, what happened here? Well, the fact is the tank, the liquid tank, shed foam, and it was the interaction of the shedding off of that tank that hit the leading edge. We didn't fully appreciate what that meant to us. And again, it resulted in a very bad day because of the interactions from a system that was not as simple as maybe others are out there. So Liberty being very, very simple, one engine on first stage, one engine on second stage, you know, obviously just that one staging event, and now you're in orbit. In addition to that, you need a very robust abort system, crew escape system, which we've got. Cost competitive. So here's one where I'm thinking, you know, maybe I could get some questions because Liberty is very, very capable. As a matter of fact, the rocket lifts 44,000 pounds into a space station orbit, which I believe is probably the largest. Matter of fact, we can lift all the other commercial capsules out there and would love to do such with our great lift capability. So given the size of our rocket and the lift capability, how can we be competitive? One of the ways is we launch the largest volume capsule to the tune of, I think, 690 cubic feet inside. Not all that is usable, but just pressurized volume space. So we can carry 7 crew, and by offering 7 crew, you obviously get more per crew. But in addition to that, our second service module will carry a significant amount of cargo. I've got a picture of that coming up, which helps a lot because it just doesn't cost me that much more to carry the cargo, but it's a great benefit to show up at a station, whether it's the NASA space station or a commercial space station. Now with the crew and the cargo that they need to the tune of 5,000 pounds, that really helps the business case. But there's one other thing on here too, and you're probably looking at the chart, streamlined. What we've done at ATK over the past 18 months is we took a look at our factory and realized that it was not operating very efficiently. And NASA, by the way, with NASA's help, we made over 400 changes to procedures. NASA's credit, they bought off on every one of them. But there were instances where a piece of hardware might move 40-something times. We were able to reduce that down into a single-digit number of times for efficiencies. So we figured out how to gain efficiencies. For me in Liberty, I'm given the manufacturing plant 1/10 the number of requirements that they're used to, or that they would have, say, for the NASA motor. And part of that is it has to do with a commercial set of rules. And we actually at ATK make motors commercially and sell them to folks such as ULA, Orbital. And we know the commercial world, and the bureaucracy is a fraction of what it can be in others. And that equates in big savings. And a lot of the savings come from schedule, which in turn means you don't have the manpower on the hook for as much time, which is the money savings. Simple design I talked about, and the performance margin. The performance margin is key in me making my launch schedule dates. Because of the margin, the extra launch lift capability I've got, I have the luxury of, as an example, on my capsule, I'm just flying the existing heat shield that Orion has been developed and certified for Orion. It's thicker and heavier than I need, but it actually, when you look at it, it gives me a safety margin, and now I don't have to take any time or expense for the certification of that heat shield. I can lift it. My composite pressure shell, I'm making it heavier and thicker than I would have to. I'm also instrumenting it to make sure I totally understand it. But rather than going with a little bit, thank you, 10 minutes, so I'm going to get to questions here quickly, with a little bit quicker design, I had the luxury of making it more robust. The amount of testing I have to do ahead of time, the amount of data I'm required to collect or have to collect is less as well, and that all helps my schedule. So here is the pressure shell. The lower right portion of that, that was just taken a month ago with that composite crew module going into a vacuum chamber for permeability testing at the Marshall Space Flight Center. And by the way, that's NASA and the industry team that's doing that testing on that composite pressure shell. I'm leveraging that work. We ATK manufactured that back in 2009. You know, 7 crew, even a toilet. And actually a toilet's a big deal. I can tell you as a crew member that that comes in very handy. You need a fairly good sized capsule to provide all those amenities. I want to get to questions. Here's my Block 2 service module. So the first one I fly will not have the capability to carry a pressurized cargo module, but in the upper left-hand quadrant you can see it's a miniature MPLM, or as NASA calls it, the Modular Logistics Module. It's about a third the size of the one the space shuttle carried, but it's the same concept. Liberty shows up at space station. The ISS uses a robotic arm to pull it out, mate it to space station, unload racks that'll go through the 4-foot opening. So not only 7 crew, but in my Block 2, I can bring 5,000 pounds of supplies along with that crew. So, you know, in summary, and I want to get to questions here because I'm down under 10 minutes. Hey, at Liberty, we're committed. We want to provide our nation with the best capability possible. We want to bring a new launch capability to the U.S. We absolutely believe we can be competitive. We're going to start flight testing in 2014. First crew launch, November of 15. We are leveraging many, many lessons learned in addition to all the streamlining and given the new set of commercial rules we've got are really moving out. But my final slide here is, the fact is, regardless of who provides the service force of a nation, here's what it's really all about.
My fondest dream is becoming an astronaut. I will see space and planets. I will hear the countdown clock. I will taste astronaut food on a mission. I will touch the controls. I will smell space. Inside I will feel happy and excited. I wrote this poem.
Okay. Test. Questions? Yes.
Say you got safety. How far are you supposed to go?
Test. Hey, mine works now.
Sorry about that. You say safety is a priority concern. My background is working on ships as a marine engineer. We wouldn't go out to sea without a workshop or somewhere to do in-situ repairs. And humans have forgetful memory of lessons learned. And I don't know how far you propose to go with that, as you set up the International Space Station, or what? Because I have a patent for repairing in situ in space. You might want to come see me after.
Thank you. I will. In our design is to do everything we can to design in the reliability requirements that we need. Sometimes that's through redundancy. In fact, many times it's done through redundancy. Other times it's done through high reliability. Our goal is, you know, to be able to sustain failures and still complete the mission. At the very least, make sure we get the crew back on Earth, and because that is one of the big differences. Is, you know, when you're flying humans with that payload, some people say, "Hey, wait a minute, we launch payloads that are worth billions of dollars, almost priceless." And absolutely, and you dearly want those payloads to get into their orbit. On the other hand, if we're launching crew members, getting them into orbit is not the priority. The priority is getting them back on the Earth safely. That's the number one priority. And they're very different.
Yeah, because it's not if, it's when you're going to have a failure. And as I say, a marine engineer would not go out to sea without some facility to do in situ repairs.
Yeah, yeah.
Okay.
So, thank you.
I better ask the question. What's your per seat price for the launch? You've no indication of price yet. And second, what's in it for the European government, if any, now that it's a US-European program, effectively? What are they after in this deal?
Yeah, hey, great question. The first one, price per seat, all I can tell you is it's significantly less than what NASA's paying for a seat now. We're still in the middle of a competition, but I think people will be very pleasantly surprised when they see our price per seat. Once we start flying cargo too, our combination of crew and cargo, I think will be extremely competitive. Second of all, the European government, when we started this project, we contacted the European Space Agency and said, hey, we want to talk to one of your manufacturers. What do you think? They said, great, go for it. We talked to Arianespace, who sells the Ariane 5 system. They said, hey, this is great. The contractor is Astrium that builds it. That's who we're teamed with. So technically, legally, right now, what Europe gets out of it, I think, is nothing other than part of our system, our U.S. system. Well, I guess what we get out of it is President Obama, a couple of years ago, when he rolled out his space policy, he had a couple major changes. One of them was expand international cooperation. So we are helping that with this project with folks that have proven to be very good partners on Space Station. 5 minutes, thanks.
Yeah, you made it sound like Liberty is a standalone company almost, at least in what I heard when you started off. So is Liberty going to be a separate profit center from ATK? Is it a spin-off? Will it be separate, et cetera? Could you talk about that?
Yes. Starting out, right now, it's ATK. We've actually, that's one where we've been kind of all over the map. Right now, with the ICAP competition going on, if we receive a full award, if you will, on ICAP, it will probably remain ATK. Because we ATK see this, it's been interesting as it's evolved, but ATK sees this as a very strong business case, and we ATK will put significant amount of cash into it on our own. If the award is less than that, now we're going to look very hard at turning it into a Liberty Corporation, in which case we'd approach equity investors or debt investors, and now as a corporation, it would wind up with some investment. So the real answer is don't know. It depends. We'll have to see what funding comes. Question over here. Oh, yes. Sorry. We'll come to you next.
What are the primary differences, if any, between the 5-segment booster you've got there and the one you're going to be building for SLS?
Very little. So the fact is, right now, SLS, the first 2 test flights, that segment is strapped on the side. Ours is in line, so it'll have a nose cone. Ours is expended as it is on SLS, interestingly, so we don't carry the chutes or have that extra 12 feet of length in there for that. But the grain design, in my commercial world, I'm not changing a thing. I don't have to. So they are very, very similar. So Rand, yeah. So the question is, hey, what happens to my cost structure if SLS is canceled? And thank you. That's a great question, because there are synergies, right, which obviously implies Liberty I can offer at a lower price with SLS. The timing is such, as long as NASA proceeds with the 2 test flights on SLS that we're on contract for now, and Liberty kicks off with an ICAP award, Liberty will be up and operating well, that if SLS, if the follow-on booster competition doesn't include the 5-segment, our costs will go up slightly, but it's actually not that great. So we have made our plant efficient. We will size it to the production that it needs with these efficiencies. So we actually at Liberty do fine up and running without SLS. And part of the reason is a lot of this hardware that NASA has for both systems, as a matter of fact, is being excess. So the hardware is there, and now it's a matter of operating the plant at an efficiency level for a rate up here or a rate here. Yes.
Thank you, Tarek Malik with Space.com. I was just curious with that international partnership, what challenges you see, or what the biggest challenge you see in terms of integration with the upper stage, the core stage are, and how you expect to either address those through hardware fittings, you know, how you see that whole process coming together.
So yeah, thank you. You know, when I went into this, I thought one of my biggest challenges would be ITAR, which are the rules levied on me working with a foreign national and particularly sending things their way. It took us a little while to get through the initial agreement. Since then, we've had the modifications. That's actually gone very well. Coming the other way, out of Europe into the U.S., they have similar ITAR. They don't call it ITAR, but they have similar export regulations and rules. Those are different from ours. And so about a year ago, we realized we didn't fully appreciate those. We had a little bit of a setback. It cost us a couple of months on working through it. So we've been working through those. Since then, EADS North America has been very involved with us, and they're based on the East Coast. So they very much understand all these rules, and it's been a great relationship. Once we're up at operational rates, which to me, I'm saying the operational rate is around 4 to 6 missions per year. EADS North America is looking at bringing the manufacturing of that second stage into the U.S., which will really help me. Today, that stage is built in France, and then it's shipped to the equator in Kourou. So it actually will have a shorter trip coming into Kennedy. So the transportation is all being demonstrated today. Integration-wise, matter of fact, in the last 3 weeks, we've had 2 face-to-face meetings, one in Florida, one in France with our partners, working really, really well together. So I've been very pleasantly surprised with how well this transatlantic relationship is going. And again, EADS North America has been somewhat key in helping making sure we understand each other well. Yes, over here.
The schedules you're talking about, assuming a fully funded CCI cap award, and if you get something less than that, what happens to your schedule?
Yeah, my schedule slips right. As a matter of fact, on ICAP, we were asked, hey, if you don't get full funding, if it's, I guess, basically 2/3 of that, what happens to your schedule? And as I recall, my schedule went out about 7 months, so with a 2/3 funding to the right. So before I was ready to fly NASA crews, so I think I still met flying a NASA crew in 2016, but anyway, about 8 months for that. And proportionally from there, it just continues to go out further to the right with less funding. 0. All right. Well, thank you, everybody. I really appreciate the time. Great questions.